This is the second video on section 12.3, sequences in series. At the end of the section 3 note, you'll find a couple of problems that ask you to tell whether a given sequence is arithmetic, geometric, or neither. Now remember in class, I told you that an arithmetic sequence is linear. So if you have a formula looking like this that can be thought of like y equals 5x plus 3, a linear equation, then you know this is linear without doing any arithmetic. Now, if you don't want to think about that, you can do the arithmetic. Plug 1 in here for n. 5 times 1 is 5, plus 3 is 8. Put 2 in for n. 5 times 2 is 10, plus 3 is 13. Put 3 in there, gives you 18. Put 4 in there, gives you 23, etc. And you can look at that sequence and say, yeah, it's arithmetic because I'm adding 5 each time. So that's a viable way to continue the problem. However, it's a lot easier to recognize this by format. So when you see that it is linear, you know right off the bat it is arithmetic. Furthermore, because it is linear, we know that this number right here is the slope. And like I said in class, the slope and the common difference are the same. The slope and the difference are the same. So that not only do you know that this is arithmetic by looking at it, you know right away what the common difference is. So say you had something like a sub n equals 6n minus 5. Because that fits y equals mx plus b, it is arithmetic, and that right there is your common difference without having to do any big fancy arithmetic. Now, before we talk about the geometric, let's look at an example of what you're really going to have to do. It says, is it arithmetic or geometric or neither? If arithmetic, name the d, and then find the sum of the first 50 terms. Well, take a look at this. You might want to think about it in this form, negative 9/11 n plus 8, because that looks a lot more like mx plus b. So right there, we do know it is arithmetic, and we know that the common difference is this number that's in front of n, which is negative 9/11. Now from there, it asks us to find the sum of the first 50 terms. You know from class we have 3 summation formulas. The first 2 are arithmetic, and the third is geometric. Since we have established that this is arithmetic, we are deciding between one of these 2. It really doesn't matter which one you use, but you can use the short form if you know the first term and the last term. And in this case, what do I mean by the last term? I mean the 50th term, because if it wants me to add up the first 50 terms, a sub 50 would be the last term. Do I find a sub 1 and a sub n? All I have to do is use this formula, which you were given, and plug in 1 for n. So I'll find a sub 1 by doing negative 9/11 times 1 plus 8. You can plug all that in your calculator, and you find out that a sub 1 equals 79/11. To find the last term, which in this case is the 50th term, I am going to plug 50 in for that n. So this is negative 9/11 times 50 plus 8. Type it in the calculator and switch it back to fraction, of course, and we end up with this being negative 362/11. So now I know the first term, I know the last term, I can use the short form. The short form says n over 2 times a1 plus an. So the sum of the first 50 terms will be n over 2, which is 50, times a1, which is 79/11, plus a sub n, which is negative 362/11. And arithmetic-wise, you can enter exactly that in the calculator. You could do one little thing and divide that out, and then enter actually 79/11 minus 362/11 times that 25, and it will give us negative 7,075/11. And this is the sum of the first 50 terms of that arithmetic sequence. So that's the story for arithmetic. For geometric, then you can, same thing, you can plug numbers in and take a look at this. So let's just take a look at this one. If I put 1 in there, put 2 in there, put 3 in there, etc., I would have a half, then a fourth, then an eighth, then a 16th. And then, remember, I'm checking to see if it's geometric. I would have to do the second term over the first term, simplify this by flipping this upside down and multiplying and simplifying, and I get a common ratio of a half. Then I've got to multiply the first term by a half and see if I really do get 1/4. I do. Then multiply that by 1/2 and see if I get 1/8. I do. Multiply 1/2 times 1/8, see if I get 1/16. I do. So that is the kind of long crank it out way to see if it is geometric and then to name what the common ratio is. Or you can use my little shortcut that says this: a geometric sequence is going to have a base raised to a power. A base raised to a power. A base raised to a power. It can even have a coefficient out here in front and still be considered geometric. Now the important thing is the base is a number, 1/2, 2/3, and the power, the exponent, is the variable. N squared has a base and a power, but it is not a geometric sequence because the variable is in the base position. So keep that in mind. Now, if I'm going to use that, I need to know one more thing. If I have 1/2 to the n, I said you could have a coefficient. You cannot have plus some other number or minus some other number. It has to just be the power with or without a coefficient. The nice thing about this is no arithmetic necessary. The base of the exponential expression is the common ratio. So for the first one, the ratio is a half. For the second one, the ratio is 2/3. So something like 6 times 1/5 raised to the nth power fits perfectly to be a geometric sequence, and the common ratio is 1/5. Now let's take a look at the geometric example here. It says arithmetic or geometric. We know it's geometric based on what I just taught you. It is geometric. And it says if geometric, name R and find the sum of the first 10 terms. The reason I just did 10 there is that when you raise something like this to a huge power, it's going to round off, and we don't want that to happen. So we're going to just do 10 terms just to show you how this works. So I'm looking for which of these is my geometric sum formula, and it's this one right here. So I'm getting ready to do S sub 10, which will equal A sub 1 times 1 minus R to the n all over 1 minus R. I do know what R is. R is this number right here. So R is a half, and because it comes out nice and neat, I would use the decimal form. You could use the fraction form, no big deal, but the decimal just makes it a little bit easier with the calculator. So I know what R is. I have to find A1 by plugging 1 in here for this n. So this is 3 times 1/2 to the 1 is just 3/2, which is 1.5. Same thing, because it comes out even, I'd rather use the decimal. So plugging this information into this formula, A sub 1 is 1.5, 1 minus R, which is 0.5, to the n, which is 10, because I want the sum of the first 10 terms. Remember, in this formula, this n and this n are the same, and R are the same. Then the bottom here is 1 minus 0.5. And then I would do at least one thing. The top looks just fine, 1 minus 0.5 to the 10. To avoid having to use parentheses, I would do this arithmetic. 1 minus 0.5 is 0.5. Now you can enter exactly what you see. 1.5, parentheses, 1 minus 0.5, caret 10, close your parentheses, and then divided by 0.5, and that works out to be 3069 over 1024. I want to go back to this one and just talk about something arithmetically, and that is you may be tempted when you look at this that you do 1 minus 0.5 and then raise that to the 10th power, but that is not order of operations. Order of operations says do your exponent first, so it has to be 0.5 to the 10th and then subtract that from 1. The other thing you may be tempted to do is from the formula, looking at that formula thinking, oh sure, I can do some sort of canceling with 1 minus R and 1 minus R to the n. You cannot. That is a binomial. That is a binomial. You cannot cancel part of a binomial with part of a binomial. Last one, same direction. It says, is it arithmetic or geometric or neither? Well, it's certainly not arithmetic because that's not linear. Forget arithmetic. It's not geometric. Yes, you look at that power, but remember, it has to be a number raised to a power. So it's not geometric, therefore it's neither, and you are finished.